Hello everyone. So today our class is going to start with this topic. So that is three-hinged arch parabolic with different end levels. So here see the structure of three-hinged arch. So parabolic having from the crown to the A and L1 distance, from the B and L2 distance. So here crown height from the B end level is H2 and here H1, and at hinge two reaction forces as usual, that is H direction and also vertical direction, and at B also horizontal thrust along H direction, and along vertical direction VB reaction force. And in this condition is externally point load W is acting left portion of the parabolic arch away from C, and it is maintaining small a distance. So in this case, so what is the horizontal thrust value? Okay, so answer is this: W into L2 into L1 minus A by H1 L2 plus H2 L1. So competitive point of view, so you have to remember this, but EST point of view, we know already analysis part, that is first make one vertical reaction forces. So here vertical reaction forces equals to upward vertical reaction force equal downward, so that is VA plus VB equals to point load. And so after developing reaction 1, so you have to find out horizontal thrust also. For that horizontal thrust, so you need to develop moment about A left side and moment about B C right side portion. So here I'm preferring here moment about C left side. So VA into L1 minus W into A and minus this H into H1 equals to 0. So here I'm following for clockwise positive and anti-clockwise negative left side portion, and right side portion so opposite to that. Suppose if you are preferring anti-clockwise negative, anti-clockwise positive, clockwise negative left side, so right side follow opposite to that. So here I'm following left side anti-clockwise negative, clockwise positive. So right side I'm following anti-clockwise positive and clockwise negative. And here reaction force is so VB into L2 and H into H2. That's it. There is no external load system, but negative or positive, so check it here. Anti-clockwise plus VB into L1 L2, and clockwise H is developing, and here minus H into H2. That's it. And from this equation 2 and 3, so write VA in terms of VA and in terms of VB. Okay, so from this third equation I'm writing, so VB equals to H into H2 by L2. Okay, so substitute this value, and from this also VA, so these two values substitute in equation 1, so equal to 2 and 3 in 1. So H into H1 by L1 plus W L1 plus H into H2 by L2 equals to W. And from this loads are separated, and only horizontal thrust and rises and length of the spans are taken separately. So here H common equals to W. From this H equals to W into L2 into L1 minus A by H1 L2 plus H2 L1. So in this way I have to find out horizontal thrust, such a kind of structures. Suppose if okay, so along the W direction, suppose 90 kilonewtons is present. Okay, gate point of view or IES point of view, so they may ask what is the horizontal thrust for this kind. So W already 90. So L2 and L1 and H1 and H2, so they have given in the given question. So directly remember this formula and substitute, and so that you will be getting H. In this way also you can find out, but it may take some time taking process. And similarly, so here also, so here tangent parabolic arch with UVL load. So here both ends are at same level, having rise h, and left and right side, so this arch is having uval, but starting with intensity less at crown point C and maximum at end levels A and B. Okay, and having same intensity here W and here also W. Remember this, and exactly they are maintaining same half, half of the distance, and here also half of the distance. Same distance and same load. It mirror image. And same. First make equation 1, that is VA plus VB equals to loads. So UDL, so area multiply with load. So half into, so this distance equals to L by 2 into W. Okay, so WL by 4. And moment about C, left side, same VA into L2, and it equals to clockwise equals to anti-clockwise, H into H plus half into, and here W into L by 2 into, so we are moving from A to C side, so I had consider from the maximum side to this, so 2/3 of this distance, that is 2/3 into this portion L by 2, VA into L2 equals to H into H plus WL square by 12. But it's a symmetrical structure, so directly you can write VB also same. Okay, otherwise you can take moment about C right side, so same answer will be coming. So that is VB equals to 12 into H plus WL square by L into 2. Okay, and substitute these values in this equation, VA plus VB, so that you'll get so this value. Okay, so this is the formula of horizontal thrust for this kind of structure having 3-hinged parabolic arch. 3-hinged parabolic. See the term first. What kind of arch? 2-hinge or 3-hinge? Parabolic or circular arch. So parabolic, 3-hinge for this and such kind of flow system. So here we'll be getting H equals to VA into L by 2 minus WL square by 12 by H. And next other one, show here circular arch. So already, so this question has had given in C1 class. So that is circular 3-hinged circular arch having point load exactly at crown point, but A and B are not having exact radius. Here R1 radius and here R2 radius. So it is a H value. Directly answer is W by 2. But W by 2, so allow and first taking moment about C. Okay, and you also VA plus VB equals to here W. So this is your equation 1, and from this for equation 2, so take a moment about C left side, so that is VA into R1 equals to H into R1. So span length and rise so are same, because in circular anywhere from one into other end, so they are maintaining equal radius R1. And here next to quarter portion, so it is maintaining here R2 radius right side, VB into R2, and substitute V and VB in this first equation. So I'll get H directly. Okay, and so last portion, okay, last derivation part. So that is 3-hinged parabolic arch having UDL at 2 different end levels. Entire UDL different end levels. So in the same ఇంతకుముందు పాయింట్ లోడ్ తీసుకున్నారు, బట్ సేమ్ డిఫరెంట్ ఎండ్ లెవెల్స్ హ్యావింగ్ పాయింట్ load away from C some small a distance, but here instead of point load it is having entire UDL H1 H2 at A and B, H and VA H VB. Answer is WL square by 2 into root H1 plus root H2 whole square. See here, W into L2 into L1 minus H2 H1 L2 plus H2 L1. Okay, see the answer దీనికి, but ఇది large. So as usual, VA plus VB equals to external load, so that is UDL W into total length L1 plus L2 equals to L W into L. So that is your load. And taking what about C left side portion. Okay, so VA into only this quarter portion, VA into L1, H into H1, and this UDL load W into L1 into L1 by 2. So it's equation 2. Similarly, C right side portion, but here distance is L2, rise is H2. Same, anti-clockwise equals to clockwise. So make a third equation and substitute 2 and 3 in 1. Okay, so here you got, so you may get this answer, W into L by 2 by H1 by L1 plus H2 by L2. So fourth equation. But so for simple అంటే in terms of HL1లో ఉంటే ఇది మనం దాన్ని ఇంకా సింపుల్గా కన్వర్ట్ చేసుకోవాలి అంటే, సో విత్ దిస్ నోట్ పాయింట్ we can convert this H2, so this formula, like already had given one formula when the end C as horizon, having coordinates x comma y be the of a point on the center line of the arch, we have the formula x square by y equals to constant. If you are applying here root for this, because it's constant, no, so root apply చేసేసి, so that is x by root y equals to constant. So apply same formula so in this. Okay, so that is x direction, so we are having L1, yes. Y direction we are having H1. So use that span length and rise. Okay, correlate span length and rise with this x and y. Okay, this formula, L1 by root H1 equals to L2 by root H2 equals to entire length. Entire length means L1 plus L2, H1 and H2. So that is L1 plus H2 by root H1 plus root H2 equals to, so you know already L1 plus L2 equals to summation of these two equals to total length of the span, L by root H1 plus root H2. So I want L1, suppose I want L2, suppose I want H1 rise, suppose I want H2. I mean in the given question, so they may give these three known and except one unknown. So with the help of this equation we can find out that unknown value easily. So L1 by root H1 equals to, okay, so equate individual quarter portion to the total portion. So that is L1 by root H1 equals to L by root H1 plus root H2. So from this, what is L1? L into root H1 by root H1 plus root H2, and L2 also L into root H2 by root H1 plus root H2. So add L1, L2 in equation 4 here. Substitute what is L1, what is L2. So after simplifying, so we can, okay, receive this formula, the H equals to WL square by 2 into root H1 plus root H2. Okay, so already this derivation having in our textbook, so page number 71. L1, L2 and H2, WL square by 2 into root H1 plus root H2 whole square